Hello, everyone. Welcome to our class today. Thanks for attending this class, which is a part of GRAITEC Beam Up event. So my name is Farshad Pourshargh. In this class, we will talk about how GRAITEC can streamline your structural analysis workflows from Revit. So we will be mostly talking about GRAITEC Advanced Design Solution. And also, I'm going to show you how our BIM workflow works in between Advanced Design, Revit, and as well Advanced Steel for steel structures. Okay, so let's go on with our slides. So normally, GRAITEC environment is the best solution for your BIM workflows. So Advanced Design actually shares the same library of Advanced Steel and as well Revit. So as you see some of the benefits here for the BIM workflows, the first one is it's the best in class BIM workflow to Revit and Advanced Steel. So you can send your models back and forward from both of those software, either a steel structure or a concrete structure. It will help with your increased productivity and efficiency in your projects. The workflow is very flexible. So you can either import, export, and also we have a synchronization option that if you want to send back a model from either Revit or Advanced Steel to AD, perform your analysis and synchronize it back inside those software. So our workflow will automatically show you all of the changes or modifications that has been done in Advanced Design, and you will have the option to accept or reject those changes. Also, you can individually manage and adapt those synchronized elements. So, for example, you can either accept all of them or accept some specific of them based on your project. So here I have some screenshots of how actually it's going to work with Advanced Design. So you can have different types of workflows here. So normally you can start from one of these Autodesk solutions. So if you have the project either in Revit or Advanced Steel, you can directly send it to Advanced Design using our GTCX format. And then you will end up in Advanced Design. Then you can perform your analysis, apply your loads, design your structure, code check it. And if everything is fine, you can send it back again through GTCX to either Revit or Advanced Steel. So this can be one workflow. It can be also another workflow. You can directly start your geometry and creating of the model from Advanced Design and then send it back to Revit or Advanced Steel. So this workflow works basically either way based on your preference and your projects. So here also I have a screenshot of the options that we have in Advanced Design to either import, export, or synchronize your models between other software. We talked about synchronization. Here is the window of synchronization in Advanced Design and Advanced Steel as well. We have it in Revit too. So depending on which software are you using or bringing in your model, you will have this window. And through this window, you will have the option to firstly see all of the changes, and as well if you want to accept them or keep them as they are in the original state. So this is the synchronization window that we have in through GRAITEC GTCX transfer. So beside the workflows, Advanced Design also has another benefits as structural engineering software. So I have listed some of them here for you. So first of all, Advanced Design supports most of the international codes like US, Canada, Euro codes, even appendixes and annexes of Eurocode. We have them in Advanced Design. The software always being updated to latest version of design codes. So we always want to keep up to date our either steel, concrete, loading, or other types of codes based on countries or standards that we have. We have always one major release and several updates after that per year to cover all of the required features as well the features that they are being asked through our clients that we are adding it to advanced design. So it's a very dynamic development environment and software with so many developers behind the scene. The modeling in advanced design is very fast and easy modeling. So it's basically like a CAD tool. It has so many features, and it makes modeling very easy in advanced design. For example, to draw a 2D frame or 3D frame, we have a snap points automatically. You can actually add your members using those snap points. You don't need to define any nodes or coordinates, etc., etc. We have climatic and crane loads generator automatically in advanced design. So advanced design is able to automatically detect the properties of the structure, the panels, and etc. Also, you can define your localization, and based on that localization or CD, specific CD, advanced design will automatically apply your climatic loads to that specific structure. And we have thousands of satisfied users around the world that they are already using advanced design. So here I have some screenshots of the points that we discussed in the previous slide. So here you see you can create very complicated geometries in advanced design. So this is like a modal analysis of the gateway arc. So very complicated models can be created easily in advanced design. Here you have a 3D frame, steel frame, created in advanced design. So we have a project pilot here, as you see. So all of the elements that you're adding to your structure will be listed in this project browser or project pilot, that you can have access to them. You can select them, hide them, delete them, or modify them much more easier. Talking about the standards, here I have listed like just Canadian and US standards. So as you see here, for load combinations, seismic, climatic, reinforced concrete, steel, and timber, we have Canadian codes, and same as here for US. And here at the bottom, I have 2 screenshots from the automatic snow load generator, and as well the wind load generator on those structures. So all of those loads will be generated automatically. And also you have the option to manually check them out to verify them. And in case if you want to change the value or the quantity of that load in advanced design, you have the option to modify those. So it's very flexible workflow and tools that we have in advanced design. So let's go now directly inside Advanced Steel and Revit, and I will show you directly how actually the BIM workflow can be used using those software in advanced design to create your geometry and basically have a full workflow of BIM in your projects. Okay, so let's go into Advanced Steel first. Okay, so I have opened the steel model in Advanced Steel. So as you see here, I have some steel elements. I have defined some foundations, and as well, we have also some concrete slabs on this structure. Just to let you know, the GTCX format or BIM workflow will also transfer all of the foundations, so they will show up or modeled as fixed supports in my structure analysis model. Also, it will be able to transfer my concrete slabs. So the workflow that I would like to use here to send my steel structures to advanced design is going to be through our Power Pack. So I will click here. And in Power Pack here, we have an export, import, or synchronization option. So in this case, I want to export my model. So I will click on export. So I have a specific folder here that I can actually save my GTCX file inside that folder. So for example, we can rename this as AS to Advanced Design, and the format will be GTCX. As I mentioned earlier, that is the standard format to transfer models from Advanced Steel to AD or vice versa. So I will save this. We click Save. So now the process of exporting is finished. To keep the model compatible, you can always save this project here. So I will click OK. Now, actually, what happened is this model has been exported, and I have the GTCX file. And now I will go and open that GTCX file inside Advanced Design, okay? Okay, I opened Advanced Design here. So this is the first page of the software. Just to show you the codes that we have here, you can always go and select your design code first. So you see here, first of all, I can select the localization. So we have Canada, US, and other countries. And based on the localization that you will select, it will automatically bring up all of the codes that you have. So you can also select other codes. We have all of them here, different versions of steel, for example, concrete, etc., etc. So I will click OK here. To import the model that we just saved in Advanced Steel, we can use the beam import option here. I will go to my folder here, which is called class, if you remember. And the file name was AS2AD. I will just call that in. Okay, so the model is imported directly. So at the beginning here, if you want to put some properties, project name, etc., you can assign them to your project here. All of those will show up in your reports later on. So in this case, I will just ignore that, click cancel. And this is the actual structure that directly imported. So I'm in a 2D view, but if I rotate it, you will see that it's exactly the same structure that we had in Advanced Steel. I have my foundations imported as rigid supports, and also I have my slabs. So in Advanced Design, you can, if you want to make modifications in this model or change properties or check properties, it's very easy. So in this case, I will just deactivate my work plane. And now, for example, if we select one of those sections here, you will see that it's an ASTM A992 material and the section which is here. And all of those properties are coming directly from Advanced Steel. You don't need to change anything. As well, I can check my supports that you will see here that it's going to be a fixed support. But in any case, if you want to modify the degrees of freedom of that support, in Advanced Design, you have different ways that you can release them or define customized supports. Same thing for my slabs. If I click on them, the slab will be supported. And here we have all of the parameters. So the material, the thickness, etc., which also can be modified here from our properties in Advanced Design. So in this case, to keep it simple, I will just apply some loads on this structure, and we can run our analysis directly on this structure. So to apply loads in Advanced Design, basically we can go to loads, and I can create several families. So we can create dead loads, we can create live loads, and etc., etc. In this case, I will start from dead loads. So we click OK. There you go. The dead load will be added. And Advanced Design will automatically calculate the self-weight of structure and assign it as a dead load. What we can do also here, I can also add a live load. And in case, as I mentioned earlier, if you want to add snow loads, wind or seismic loads, or any other type of loads that you see here, for example, crane loads, we have an automatic crane load generator as well in Advanced Design. So you can just select them and add those load case. So in this case, I will go with live load, click OK. My live load family is selected. And adding or applying loads in Advanced Design is also very simple. So it's not related to the elements. It's completely separate than the elements of the structure. So you can put any type of load in those slabs. So for example, in this case, I can simply go, you can have 3 types of loads, point, linear, and planar. I go with planar. I can put my intensity here. So for example, in Z direction, minus 20 pound per square feet. And I am in US or imperial units. But to change the units in Advanced Design, it's also very simple. You can just double click here and either change it to metric, or you can also have customized units based on your preference. So now that I have put my force there, I can simply go click on the corners. As you see there, it's very simple. And there you go. I have added my loads there. If you want to see them more clear, I can change my scale. and that's going to be my uniform load on that specific roof. So the next step is going to be creating our basically load combinations based on the load cases. So it's going to be here. You double click here. You have several options here. You can either define your load combinations manually by using this option here. You can import or export them from Excel, or you can use the automatic load combination generator in Advanced Design. So you click there. I can keep it here, generate, and there you go. It's going to automatically create all of the possible load combinations based on your load cases. And as well, the automatic factors for each load case will be created automatically, as you see there. I can click OK there. And now what we can do is you can simply do a steel design. So I can click there. We can do a steel calculation. The process is almost similar to concrete structures. You can do a similar for concrete members and structures. And also in Advanced Design, you can have a combined structure. So you can have both timber, concrete elements, and even timber elements in the same model. So I will click OK, and we will start the analysis. So as you see, automatically, Advanced Design will mesh the structure and connect everything. So also, we have an automatic option here that Advanced Design can automatically detect some continuous members. So in case if you want to make a member continuous, you can use the super element option. So in this case, I've just ignored that. So all of our members will be just in the length of the span. Okay, so now the analysis has completed. I can first check my displacement. You click there, and there you go. This is going to be the displacement. And again, I am in imperial units, so it's showing me in inches. So as you see, it's a full 3D rendered option. The other things that you can have in Advanced Design, basically, you can have your internal forces for the members. I can simply go to forces, and I can select, for example, my FX forces, which is going to be the actual force in elements. And you can also select which load combination or load case you want to see those forces. So you can simply go there, and now it's going to be based on that load combination. If you want to check the moment, again, very simple. We have the moments here, MZ, weak axis, strong axis, torsion, etc., etc. You can check them from here. So it's very simple to check all of your results in Advanced Design. As well, I have my steel calculation here. So you can simply check the strengths, and you can either check them one by one, or you can have the max one. So you click max, and here, there you go. I can see by color codes that which members are critical. So in this case, these members are 45%. Again, they are below 100%. But in this case, those are the ones that they are working with a maximum workload ratio. So obviously, I can optimize this structure to have a better cost-effect structure. So if you want to check even in more detail how Advanced Design is designing or code checking this, let's say this column here, you can select the column and go to our design sheets. And here you will have all of the cross-section properties, deflection checks, and also how we are getting or calculating the resistances. So you will see all of the clauses. In this case, I'm in Canadian code, so it's going to be S16. You see the resistance and apply moment, shear, actual force, and combined here, etc., etc. So that's very easy. And also, if you want to create even a detailed report of those, you can just click on Edit Detail Report or Edit Report, and it's going to also show you the full report of the steel design. Also in Advanced Design, we can ask for optimization. So we have a tool that you can optimize your sections. For example, you can go there, and here for optimization. So here Advanced Design will automatically do optimization for you and basically create or give you optimized members that you can use for that specific column or beam, etc., etc. So also Advanced Design comes with a very good optimization tool to optimize your steel structures. So this is actually how it works in advanced design. You can actually, if in case you want to change a column or something in advanced design because of the design requirements, you can change it here and synchronize back this model into advanced steel. So for example, in this case, what I can do is I can, let's say, select this column. It's a W8 by 31. So I can go to our libraries. So ASTW, that's a W8 by 31. So for example, let's say for any reason we want to change it to W48. Okay, I can click there. Now it's changed to a W84, as you see there. You can just double check. Yeah, W848. So now I can synchronize back this model to advanced steel, and you will see that automatically advanced design will detect that column that the section is changed in advanced design. Okay, so let's send back this model to advanced steel. So it's going to be very simple. We go to Beam again in advanced design, and here we are going to be exporting this model back to advanced steel. So we click export, and now same folder. You can have a different name for this export, so I can call it AD to AS. Okay, click save. Now it's going to be saved, and now I can go back to advanced steel and synchronize back my model. Okay, since we are here, I would also like to show you the same workflow from Revit. So I have the same structure here in Revit, and we will try to also export this structure from Revit to advanced design. So similar to advanced steel, we have our power pack here. I can simply go there, and here in the Beam Connect options, I can click export. Then obviously you have some options here that you can select because, as you know, GTCX format can also transfer loads from Revit models to advanced design. So I can click OK. And now I will go back to my class folder here, and we can save this file as another name because this export is going to be from Revit. So I can name it Revit to AD and click save. So now it's actually exporting it, and if you want to do some mapping, you can do it here. In this case, I will not, so I will click not for all. Okay, if you want to generate a report to see what kind of elements, how many elements have been exported, you can always click yes, and it's going to show you the report. In this case, we just click no. And now let's go back to advanced design, and this time I'm going to import this model from Revit. Okay. Okay, we are back into advanced design, and similar to AS import, I will use the Beam import option. We come here into the class folder, and as you see here, the file is here, Revit to AD, GTCX. I will select and click open. And there you go. As you saw again, here I have the same structure which is coming from Revit. And if you check here, because the model is coming in from Revit, and Revit, we have the option to define loads. So the loads also will come in directly from Revit. So if I auto scale them, you will see that I have already some loads on this structure which are directly coming from Revit. So the process from here, it's going to be almost the same. You can run your analysis, perform the code checks, and you can also send back this model into Revit or synchronize it back. Okay, so this was like a brief overview of how you can use our Beam workflow for steel. And as I mentioned, it's going to be almost the same process for concrete structures. So let's go back to our slides. Okay, so thanks again for your attention to this class. So obviously, if you have any questions later on, or if you want to try this Beam workflow using advanced design, please let us know. And for any questions, as you see here, we have support.us@graitec.com. and support.canada@greatec.com emails that you can always send us your questions. So now it's the time for a Q&A, questions and answers. So in case if you have any questions, please use the chat tool. We will try to answer your questions. And in any case, if you have other questions later on, please use our emails that I mentioned in the previous slide.
All right. So thank you guys so much. And thank you, Farshad. I did get a comment in the chat from MD Nihal, but MD, I actually don't quite understand the question or comment. Maybe you would, Farshad. He said Indian code is there.
No, we do not have Indian code yet. Yeah, so it's mostly North American codes and European codes for all of countries. Yeah.
Okay, perfect. Thank you. All right, guys. Yeah, so if you have any questions, you can go ahead and throw them in the chat box. We've got Farshad here to answer them. And what was that email address if they think of any questions afterwards? I'm going to put that in the chat box.
Yeah, actually, it's support.us@greatec.com.
Okay, I'm going to throw that in there.
Yeah, and the other one is going to be for Canadian clients. So it's same thing, support.canada@greatec.com.
All right. I threw that in the chat, guys. If you're like, I like the webinar and I just forgot to ask this question, you can email that. We'll get you the right person with the right answers. All right. The computer did a little restart there, but I'm here. All right. Farshad, when you gave this class in BIMUP, was there a common question that was asked or whenever you do this training for others?
Not really. Like one question can be, is this the only way to create models in advanced design or send the models to advanced design? But it is not. So as I mentioned in the presentation, you can even start your model directly from advanced design, you know. So we have a good CAD tools there that you can create very complicated structures. And after the engineer has done the analysis and design, then you can send it even to either Revit or Advanced Steel. There are also some questions because this webinar was focused on steel mainly. Some questions on concrete. So yeah, like the procedure for concrete structure is almost the same. And for concrete structure, we have even more stuff. Like, for example, if in some of your projects, let's say you have concrete foundations or you have concrete beams and columns. So in advanced design and as well in Revit, we have tools. GRAITEC has tools that you can actually detail your concrete structure there. So you can put your rebars inside the elements and we can create you bar schedules, we can create drawings, and you can modify those as well. One question that maybe can be interesting here is also like for seismic analysis and design. So we have it in advanced design, so based on US, Canada, and European codes. So basically, if you want to do spectral analysis, linear analysis, even pushover analysis for seismic lateral forces, we have them defined in, automatically actually defined in advanced design. One question that it can be also asked is our GTCX format. So in case of advanced steel to advanced design, well, there are no internal loads inside your members, okay? Or if you send back that model from advanced design, you cannot use it in advanced steel. But in Revit, actually, our GTCX tool can also import all of the internal forces and rebar areas inside the elements to Revit. And how you can use those information in Revit using our power packs, like GRAITEC power packs. You can also do your detailing and drawings inside Revit using your design results or analysis results that we are coming from advanced design. Those are like the main ones that I remember. But anyway, if anyone has questions, don't hesitate. Yeah.